chapter 11.5a is a normal distribution. The good news is there's only 4 lessons left. That's a lie. There's only 3 lessons left. Better news, these lessons are so technically specific that we will basically see them, take basic notes, which that's if you, on things I kind of tell you what to write, because you really don't have to write everything, and answer a couple of questions about them on Math Excel to make sure they're in your brain and that you can at least answer them. The majority of the last 2 sections is for your experience and basic understanding. We will be required to understand some basic parts, but these lessons are more about discussion, which means just listening to what is going on, and proof of understanding, which means take some of the basic stuff I show you, go over to Math Excel and answer the questions. The normal distribution is a bell curve. It represents the typical curve as n approaches a complete population. If you think about the sample size, remember I told you that the sample size, as it's small, is going to be kind of, not really representative of everything. And then we talked about how it was negatively skewed and positively skewed. Well, the general idea is that as you approach the complete population, it starts to look more like a bell curve. If you remember that bell curve I showed you whenever I talked about certain things, and that's what it is. The mean, median, and mode are equal and centered. The curve approaches but never touches the x-axis, and the total area under the curve is 100%. So what you're looking at in the curve is this part here. All right. The curve itself has a look that's something like this. Don't copy this yet. I'll give you another chance to do that, but just kind of look at it and follow along. And the note is that 99% of the data is between -3 and 3. So you have a 0, you have a 1, 2, 3, -1, -2, -3. 99.7% of the population is going to fit here. I don't know if you remember when I was making that statement about people who are really, really smart and people who are really, really unsmart, and I said there's a really small percentage of the population who will never get anything wrong, just like there's a really, really small percentage of the population who will never, ever, ever get anything right. Let's just check that out real quick. 0.15%. And there are, I think, 1,200 students in Southeast High School. No, I'm sorry, it's 0.015%, so 0.00. Actually, let me do it this way. 0.15. Let me cheat. Where's the percent button? It's not there. Let me use another calculator that will help me cheat better, because I'm not working so well at 5 o'clock in the morning today. 0.15% is that number. 0.0015, which I think I was going to do, times 1,200, which means that there is about 1.8 students in the whole school, based off of this, who will never get anything wrong. And then there's about 1.8 students in the whole school who will never get anything right. Now, that's not a judgment at all on either side, but I'm just saying in terms of the population, it means that about 1.8 people in this school who are probably genius, and I'm talking from freshman all the way over to senior level, everybody. So again, that's how the population typically works. Most of us are typically within this range, which is fine. Remember, work ethic makes a difference in all that anyway. The numbers 1, -1, and so on represent the number of standard deviations away. So this would be your mean, and so this would be 1 standard deviation, 2 standard deviations, 3 standard deviations, because remember, you're basing everything off of the mean. In textbooks, you might see them listed as this, which is a symbol for mean now, because remember, that's your expected value, but if it's the whole population, the expected value is your mean. So that'll be mean plus, I think it's sigma for the 1. So that would be, this would be whatever your mean is plus whatever your deviation is. This would be whatever your mean is plus 2 deviations. This would be your mean plus 3 deviations. Just like that would be mean minus 2 deviations for your -2, mu minus 3 or whatever. But again, the first thing you would have to do is determine the percentage of the population within the range, and so that's where you want to make sure you know what's going on. And so one of the things it's going to ask you to do, and again, no need to write anything yet, just following, it's going to give you something like the normal distribution has a mean of 21 and a standard deviation of 4. They want the range of values to represent the middle 68% of the population. So again, looking at the middle 68%, that would be from here to here as I destroy the whole picture here for you. But the middle 68 is this. And so notice that the middle 68 is one standard deviation away from the mean. And so what you're looking at is, in this problem, if the mean is 21 and your standard deviation is 4, you add 4, which makes 25. You subtract 4, which makes what? 17. And so your range would be from 17 to, I guess you would put 17 less than or equal to, or 17 less than whatever the value is, which is less than 25. I don't know how the computer is going to ask you to do it, but that's the general idea. You know your mean is the middle. Again, that's this number here. And you want the middle 68%, that's going to be this part. And so you're looking for one standard deviation back from the mean and one standard deviation up from the mean. And that's going to be what you're going to put down. I put it in the wrong spot. That's supposed to be up there. What percent of the data will be greater than 29%? Interesting. I think I typed that wrong. Greater than 29%. I think you have to do that. I'm pretty sure they want to know what value is going to be greater than 29%. And I think what you have to do on this is, let's see, no, I don't think that's going to be right. I think I screwed that problem up royally. But just ask me about that if it pops up. I apologize. I don't think that problem's even going to be there, but sorry. There's nothing I can do at this point because I don't even have the book around me. I did get it out of the book. Example, the heights of 1,800 adults are normally distributed with a mean of 70 inches and a standard deviation of 2 inches. About how many adults are between 66 and 74 inches? Alright, so again, this question here is giving you a mean, it's giving you a standard deviation. Sorry, I'm throwing my papers away so I don't mess the room up for my wife. It's giving you a standard deviation, it's giving you a mean, and then it's giving you a range. And again, what you want to do here is, the key on these problems, especially the ones for the normal distribution, are that you find the standard deviation. So you have this number. So what you want to do is take 70 minus 66, because you want to find out, or 66 minus 70, however you want to do it, to find out that this is the distance. But if the deviation is 2, that would be 2 standard deviations. Alright, so that would be 2 deviations that way. 74, of course, is 4 away from 70. I don't think I need to do this, but just for the sake of making sure we go through the process, and then knowing that the standard deviation is 2, that means that this is also 2 deviations. And so going back to your picture, we are going from, again, -2 all the way over to +2, which means we have these percentages included, which is 13.5 plus 13.5 plus 34 plus 34, which is going to be 95% of your population. Alright. Then it says, what is the probability that a random adult is more than 72 inches tall? Again, this is not really a probability problem as much as it is just looking at this table and making sure you know what you're doing. 72 inches based off of the mean of 70. Again, 72 minus 70 is 2, and based off of the standard deviation of 2, that is 1 deviation. And so what you're looking at is 1 deviation, and you want to be taller than 72, so you're looking at everything over here. And so that's where you're going to add all those percentages over there, which is 13.5 plus 2.35 plus 0.15, which is 16%. And so again, the general idea here is that you make sure that you look at that chart and get everything you need from it. It is going to be popping up pretty soon. But again, the idea is, communicate with me, email me if you're having issues, because I can help you understand that a little bit better as long as you show me the picture and let me know, show me what you typed in so I can see if that makes sense. But do not be intimidated by the chart. If you were in a statistics class, you would have time to memorize it and perfect your skills. For today, just simply copy a cheap representation of this thing so you at least have the numbers. Again, 0 in the middle, and then you have 1, 2, 3, 1, 2, 3, 34, 13.5, 2.35.15. Alright, so you might want to pause that so you can copy that. But the final process for you to understand, the final process for you to understand today is more relevant. That means you can actually use it more than that silly chart. The weakness with the chart is that it's based only on perfect deviation values. But what if I want to know the distance of any given value? And that's what we're going to talk about. That is really going to wrap this up. The z value of any value x is found using the formula z equals whatever your value is minus the mean divided by a deviation. That makes sense though, because if you're on the mean, it should be 0. The mean itself minus itself is going to be 0 over that, which means that you should be right here. And so you take your value, you subtract it from the mean, and you divide by whatever your deviations are, because you want to know how many deviations you are away from the mean. So jot that value, formula down. That's going to be important today and tomorrow, which is actually today for some of you. But it's pretty straightforward. Again, I'm not trying to overwhelm you with stuff that's weird, but this is it. It says find z if x equals 18, mu, which is your mean, equals 22, and your standard deviation is 3.1. So again, you simply plug it in. It's going to be whatever my value is minus the mean over whatever the deviation is. So 18 minus 22 over 3.1. Please don't forget, whenever you do that in your calculator, to type or enter first, because if you do 18 minus 22 divided by 3.1, just discussion wise, order of operations is going to do that first and then subtract it from 18. So you do want to make sure that you hit enter first and then divide by 3.1, just to be a programming safe person, and that is negative 1.29. So based off of that chart that we saw, again, I got to steal this paper again, that would put you negative 1.29. That would mean that you're about, that would be 1.5, 1.25, so somewhere around here. But again, the z value actually doesn't fit exactly off of the perfect deviation. It gives you a better range of where you would fit in terms of that part there. Alright. Another example, normal distribution has a mean of 98 and a standard deviation of 3. What is the z value of 102? Again, all you have to do is take you want the z value. It's always going to give you all the information you need. That is the beauty of statistics formulas, is that either they give it to you or you'll be trained in methods to find it. But again, x is the value that you have, which is 102, minus the mean, which is 98, over the standard deviation, which is 3. And so you simply do 102 minus 98 equals, divided by 3 equals, which gives us 1.33. Again, in terms of that, if this was your graph, 1.33 would be somewhere around here, and so you know that that's where it would be located. Now the thing about z-value is that it does not work with the percentages, but it does, like I said, it gives you a perfect location of whatever number you're looking at, because how many times am I going to, because if I'm looking at standard deviation of 3, the only numbers I could use with the chart is 101, because that's plus 3, 104, because that's plus 6, and so on. I can only use jumps of 3, and you never know what number you're actually going to need. So tomorrow will not require much outside of watching a video and me using technology to find probabilities based on z-value, because I want you to see that you can do it. Be sure to complete the homework with 100% before moving on. I actually am going to record this right now, this morning, so that those of you who are working with me, remember I told you about the percentages, this part here, how it's a very small percent. Well, there's a very small percentage of you who actually started working way back when you should have, which was right after the break, and you actually might be finishing tomorrow, which is April 28th for me and for them. But yeah, like I said, I'm going to go ahead and put that video up today so you can actually see it. But just make sure you know how to do the z-value first, because otherwise it'll be kind of useless. Again, be sure to complete it before moving on. There will not be homework on the next video. But if you do not understand how normal distribution and z-value work, then it's not a lesson that will actually mean anything to you. So like I said, I'm putting it up next, but please don't watch that. And if you want to watch it today, that's fine. Or the same day, that's fine. But don't watch it until you understand how to find the z-value, and that you see in your homework with 100% that you know how to actually answer those questions. Alright, so good luck.